Okay, so this is partial fraction decomposition. And what we're going to do is we're going to take a fraction that looks kind of complicated. So here's a complicated fraction. And we're going to break it into two parts that are simpler fractions so that when you add it together, you would get this complicated fraction. So if you recall, if you had 3 over x minus 4 plus 2 over x plus 3, how would you add those two fractions together? You would have to get a common denominator, right? So you can see here I got common denominators, and then here is what these two fractions added together equals. 5x plus 1 over x squared minus x minus 12. So what we're going to do today is we're going to take a fraction that's complicated, and we're going to break it apart, which is what decomposition means, into two simpler parts. So here are the 5 steps. We're going to go over those 5 steps as we go through example number 4. And we're going to start with 5x minus 10 over 2x squared plus denominator here. And we have 2x squared plus 3x minus 2. And notice that factors into 2x subtract 1 and x plus 2. So that's the first thing you do, is you factor the denominator. Then you're going to take this complicated fraction and you're going to set it equal to two parts. So you've got a, and we don't know what a is. We don't know what the numerator is yet. So we have a over 2x subtract 1 plus b over x plus 2. And what we're going to try to do is figure out what a and b are. And then we've broken this fraction into two parts that we would add together to get this original fraction. Second thing you do is you're going to find the least common denominator, and you're going to clear out the fractions. So we're going to multiply this whole thing by the least common denominator. And so the least common denominator is we have a 2x subtract 1 and we have an x plus 2. And we're going to take that denominator and we're going to multiply it to every part of the equation. And that's going to clear out the fractions for us. So if we take the first fraction and multiply it by 2x minus 1 and x plus 2, do you notice that both of those factors are going to cancel? So all of that cancels, and now you're just left with 5x minus 10 equals, and then we have this fraction right here. The 2x minus 1 is going to cancel with the 2x minus 1, but then you're left with a times x plus 2. So this would be a times x plus 2. And then we have x plus 2 is going to cancel with x plus 2, and that's going to leave us with b times 2x subtract 1. So we'll take plus b times 2x subtract 1. All right, are you guys good so far? Any questions? All right, so we're going to keep going. So now what we're going to do is just distribute the a and the b. So we have 5x subtract 10 equals ax plus 2a plus 2 times b times x is 2bx minus b. So I just distributed the a and the b. Then what we're going to do is we're going to gather together all of our x's. So here's an ax, here's a 2bx. We're going to put those by each other. So we're just going to use commutative properties. So 5x minus 10 equals ax plus 2bx plus 2a subtract b. Now we're going to write a system of equations, which is step 4. So to write a system of equations, what we're going to do is we're going to take the 5x and we're going to put it equal to the part with the x's in it. And then we're going to take the negative 10, and we're going to put it equal to the part without the x's. And we're going to have two equations. So here we go. First equation, let's start with this part on the right, ax plus 2bx. So I have ax plus 2bx equals 5x. And then I have 2a minus b, 2a subtract b, is equal to negative 10. So I set up two equations. Now this first equation, let's come over to our Cornell and let's write that down. So I have ax plus 2bx equals 5x. On the left-hand side, what can I factor out? X. Okay, let's factor out x. So now I have a plus 2b equals 5x. And I factored that x out in front. Then you can actually divide by that x. And so the x's are going to cancel out, and I'm left with a plus 2b equals 5. So this first equation, if every term has an x in it, that x is going to divide out. So I just divided out the x's, and I showed you over here in the Cornell. All right, so we have 2a. So over here we have a plus 2b is equal to 5. And then I have 2a subtract b is equal to negative 10. So I have two equations in two variables. So now we have to decide, do we want to eliminate the a's or do we want to eliminate the b's? What do you guys prefer? Okay, so where I got the 2a minus b equals negative 10 is, if you look at up here, I took the ax and the 2bx and I grouped it. And then I took the 2a and the negative b and I grouped it. And then I set the x part equal to 5x, and I set the 2a subtract b part of the equation equal to negative 10. So I set my x's equal to each other and everything else equal to each other. Good? Got it? All right, good question. Okay, so now let's eliminate b's, because I like that this is positive and that this one's negative. So let's eliminate b's. So this second equation, what do you have to multiply it by to get rid of the b? Ooh, sorry, didn't mean to zoom that far out. What do I multiply that second equation by? 2. Ooh, this is great as it's recording. Zooming in and out. Okay, so let's go ahead and multiply that second equation by 2. So do that right now. Trying to get everything on the screen. So second equation by 2. And that's going to give me 4a subtract 2b is equal to negative 10. And then the first equation I'm just going to recopy. So the first equation was a plus 2b is equal to 5. So 4a plus 1a is, did we mess up on that? 4a minus 2b equals, oh, thank you, negative 20. Very important. Thank you. All right, so now let's add those two equations. So we have 1a plus 4a is 5a. So here's 5a. The b's cancel. And negative 20 plus 5 is negative 15. So we're going to divide by 5. And a equals negative 3. And now we figured out what a is, we have to figure out what b is. So let's figure out what b is now. So you take one of the equations. Let's just take a plus 2b equals 5. And let's plug in a. So negative 3 plus 2b equals 5. And then add the 3. So 2b equals 8. Divide by 2. And b is equal to 4. Now, we are not done because we found A and we found B, but what are we trying to do? We're trying to write a partial fraction decomposition. So what we're going to do is go up to the top of our problem, and we're going to actually write the broken up fractions, okay? So if we come up to the top, and you look right here, you would have A, which is negative 3 over the 2x subtract 1, and then you would have B, which is 4 over the x plus 2. The negative number doesn't look really great in front, so let's go ahead and put this B over x plus 2 first. So it's 4 over x plus 2, so there's the first fraction. And then, since a is negative, we can put the negative in the middle. So it's negative 3. So there's what the negative 3 looks like, is subtract 3 over 2x subtract 1. Now, if you had written this, so if you had written this in the other order, no problem, it would still be right. It's just this looks a little bit better, putting the negative in the middle. A over x minus 1 plus b over x minus 1. If I were to add those two fractions together, would I get x squared minus 2x plus 1? I wouldn't, because how many of these do I need? 2 of them. So what we're going to do is the first fraction is just x minus 1 on the bottom, but the second fraction is going to be x minus 1 times x minus 1. You need 2 of those, so that when you add these fractions together, you get the x squared minus 2x plus 1. So you only do that when these are identical, when they're repeated linear factors, all right? So let's go to step number 2. So step number 1 is factor the denominator. Step number 2 is so here's the setup, and we're going to multiply out the fractions just like we did before. I have x minus 1, and then this one is x minus 1 times x minus 1, or x minus 1 squared. So we're going to multiply this whole thing by x minus 1 times x minus 1. Or you could write it as x minus 1 squared if you wanted. I put that in the Cornell. So I can multiply the whole thing by this or this. They're the same thing. And that's the least common denominator. All right, we should clear out all the fractions. Here we go. X minus 1 squared. There's 2 of them. So this is the original fraction, and I'm going to break it up into 2 simpler fractions. If the denominator is linear, we have an a on the top, and if it's a repeated linear, we have a b on the top. So I'm looking for a and b, and then I can write the fractions broken up. All right, so here we go. This is going to cancel, leaving me just x plus 2 equals, and then the x minus 1 cancels with one of them, leaving me a times x minus 1 plus, and then x minus 1, there's 2 of them, it cancels with both of them, leaving me just b. Okay, let's distribute the a. Here we go. x plus 2 equals ax subtract a plus b. Okay, we're going to put our x part equal, and then we're going to put everything else equal, and we're going to set up a system of equations. So 2 equations. Try it. Set up 2 equations for me. So the first equation should be ax equals x. The second equation is the opposite of a plus b is equal to 2. So if I take x and divide it to the other side, do you know what x over x equals? 1. X over x equals 1. So a is equal to 1. The x's divide out and give you a 1. Same thing on top as the bottom is 1. And if a is 1, let's figure out what b is. So this would be the opposite, and then plug in a, which is 1, plus b is equal to 2. So I'm trying to figure out what b is. Add the 1, and b equals 3. So a is 1, and b is 3. And let's write the partial fraction decomposition. So the original fraction is x plus 2 over x squared subtract 2x plus 1. That's going to be equal to 2 simpler fractions. What are we adding together to get this? We are adding together 1 over x minus 1 plus b, so 3 over x minus 1 squared. Or you could write it as x minus 1 times x minus 1. A minus b, so x subtract 2. A squared, which is x squared, plus a times b, 2x, plus b squared, which is 4. All right, so that's the first step, is all into the different parts. So we have a over x subtract 2. And now this is where it's going to be different than before. Plus, the denominator is quadratic, x squared plus 2x plus 4. So the numerator is going to be linear, which is mx plus b, or you could say bx plus c. So bx plus c is a line. Our goal now is to find a, b, and c and break this complicated fraction up into smaller pieces. Okay, multiply the whole thing by the LCD. The LCD is x subtract 2 and x squared plus 2x plus 4. And you're going to multiply that to every single part of the equation. And we're going to cancel out denominators. So this is step 3. Clear the fraction by multiplying by the LCD. First fraction, both cancel, and you're left with just 8x squared plus 5x plus 18 equals. Second fraction, the x minus 2 cancels with the x minus 2, and we're left with a times x squared plus 2x plus 4. Plus the x squared plus 2x plus 4 cancels with the x squared plus 2x plus 4, but we're left with bx plus c times x subtract 2. So let's write those down. bx plus c times x subtract 2. All right, next thing we're going to do is multiply everything through. So will you guys take the a and distribute it? So take your a and distribute it. The left side of the equation you just recopy. 8x squared plus 5x plus 18 equals ax squared plus 2ax plus 4a plus, how are we going to multiply these two binomials? We're going to FOIL. Yeah, we have to FOIL here. First, outer, inner, last. So bx times x is, what you guys? Bx times x is bx squared. Negative 2 times bx is negative 2bx. Insides, c times x is cx, and then c times negative 2 is negative 2c. Okay, are we ready for this? We are going to take our x squareds, and we're going to put them equal to all of the terms with x squareds in them. We're going to take our x's and put them equal to all of the terms with x's in them. We're going to take 18 and put it equal to 4a and negative 2c. If you were missing something over on the left, say you had no x squareds, then you would put the x squareds equal to 0. All right, so we're going to write up a system of equations in 3 equations. Here we go. First equation. I always start on this side over here on the right. So I have ax squared. I have bx squared. And that's going to be equal to 8x squared. Next one. So, and you could cross them off as you go to make sure you get everything. I have 2ax. I have negative 2bx. And I have plus cx is equal to 5x. And last equation. 4a subtract 2c is equal to 18, right? Did we get everything? I hope. Yep, I think you got everything. All right, first equation. Do you guys notice the x squared will divide out? So divide the x squared out, and we get a plus b equals 8. Second equation, everything has x's, so the x's will divide out. And we have 2a subtract 2b plus c equals 5. Last equation is 4a subtract 2c equals